Friends, I'm Meenal and you're watching Meenal Ka channel. Today we are going to learn how to solve linear programming problem by graphical method. See, this is the question. This is our objective function. Maximize z is equal to 5x1 plus 3x2. This is our objective function. Constraint subject to 3x1 plus 5x2 is less than equals to 15. 5x1 plus 2x2 is less than equals to 10, and non-negativity restrictions x1 and x2 is greater than equals to 0. Now for solving this for simplex with simplex method, first of all we have to convert these inequalities in the form of equalities, and for converting these inequalities we have to add slack variables. So friends, let's start. As there are two constraints, we will add two slack variables. So the objective function will be maximize z is equal to 5x1 plus 3x2 plus our first slack variable x3, and coefficient of x3 is 0. So 0x3. Second slack variable, coefficient of that slack variable is also 0. So this is 0x4. This is our second slack variable. Now the objective function, constraint subject to 3x1 plus 5x2 plus x3 is equals to 15. x3 is slack variable. 5x1 plus 2x2 plus x4, and here x4 is slack variable. This is our first equation, second equation, and third equation. At last, our non-negativity restrictions x1, x2, x3, and x4 greater than equals to 0. So this is our linear programming problem. This is our standard form of problem. We converted these inequalities into equalities and we found this standard form of problem. Now for solving this, we have to construct a simplex table. This is the set format. We have to construct a simplex table. Look, this is the this is the standard form of simplex table. Here we write Cj. What is Cj? Cj is the coordinates of variables of z, this objective function. Cj is the coefficients of x1, x2, x3, and x4. x1, x2, x3, and x4 are the variables of objective function. So here Cj is, first coefficient of x1 is 5 and variable is x1. Coefficient of x2 is 3 and variable is x2. Coefficient of x3 is 0, variable is x3. Coefficient of x4 is 0 and variable is x4. So this is how we write Cj. These are the basic variables. Now what is Cb? And Cb is the coefficients of two slack variables. Two slack variables x2 and x3. So variables are x3 and x4. Coefficients are 0 and 0. Here we will write the basic matrix. Basic matrix will be formed by the coefficients of these subject to conditions or the coefficient of constraints. So in the first constraint, coefficient of x1 is 3. Here you can see in the second constraint, coefficient of x1 is 5. In first constraint, coefficient of x2 is 5. In second constraint, coefficient of x2 is 2. So now in first constraint, coefficient of x3 is 1. In second constraint, x3 doesn't exist. That means coefficient of x3 is 0. So x4 in first constraint, coefficient of x4, x4 is not exist, that means coefficient of x4 is 0. Coefficient of, in second constraint, coefficient of x4 is 1. So this is our basic matrix. Now the solution is equals to, this is 15 and this is 10. This is how we construct simplex table. Let me explain this once again. This is Cj. Cj is the coefficient of variables of objective function. This is the objective function and the coefficients are 5, 3, 0, 0, 5, 3, 0, 0. 5 is variable, 5 is coefficient of x1, 3 is coefficient of x2, 0 is coefficient of x3, and this 0 is coefficient of x4. So objective function z is equals to 5x1 plus 3x2 plus 0x3 plus 0x4. This is coefficients of basic variables. Basic variables are two slack variables, x3 and x4. Coefficient of x3 and x4 are 0 and 0. So here we put 0 and 0. So, and the variables are x3 and x4. This is our basic matrix. Basic matrix is 3x1. This is 3 plus 5x2, 5x2 plus x3. x3, coefficient of x3 is 1. Here no x4, that means coefficient of x4 is 0 and the solution is equals to 15. This is our second constraint, 5x1, this is 5, 2x2, this is 2. Here no x3, that means coefficient of x3 is 0. Then x4, that means coefficient of x4 is 1. So here it is 1 and the solution is 10. Now we have to calculate Zz. For calculating Zz, there is formula for calculating Zz. Zz is equals to summation CBI into AIJ. But we will calculate this in very simple method. Zz is 5 into 0 plus, 3 into 0 plus 5 into 0. So here we will get Zz. This is 3 into 0 plus 5 into 0. This is equals to 0 plus 0, 0. So here Zz is 0. 5 is 5 into 0 plus 2 into 0 plus 2 into 0. So this is equals to again 0 plus 0, 0. This is also 1 into 0 plus 0 into 0. So 0 plus 0 is equals to 0. 0 into 0 plus 0 into 0 is equals to 0. Here all the CBs are 0. So all the values of ZZs are 0. Now again we have to calculate what? We have to calculate ZZ minus CJ. So this is ZZ and this is CJ. We have to subtract these. So 0 minus 5 is equals to minus 5. 0 minus 3 is equals to minus 3. 0 minus 0 is equals to 0. 0 minus 0, this is also equals to 0. Now we have to maximize the function. So there is condition for maximizing the function. For optimum solution, for maximize, all Zz minus Cj must be greater than equals to 0. And for minimization problem, all Zz minus Cj must less than equals to 0. This is a maximization problem. So in this case, for optimum solution, all Zz minus Cj must be greater than equals to 0. But here 2 Cj's are 0 and 2 are negative. So we have to go for another simplex table or next for next step. So for second iteration, this is Cj. Cj with the same value which was in first iteration. This is 5, 3, 0, 0. There will be no change in Cj. 0, 0. Corresponding variables x1, x2, x3 and x4. Now 5 is the key element, and this row will this row, that means the variable x4 will be the departing vector, and this 5, this column will be the entering vector. So in place of x4, here we will put x1, the entering variable. This will remain same as it was in first iteration. X3, coefficient of x3 is 0, coefficient of x1 is 5, here we will put 5. Now we have to calculate the values of basic matrix. First we will calculate the second row, the row of key element. For calculating this, we will divide all the numbers with this key element. That means 5 upon 5, this is 5 upon 5 is equals to 1. Then 2 upon 5, 2 upon 5, 0 upon 5, 0 upon 5 is 0. And this is 1 upon 5, 1 upon 5. Now we have to calculate this row 1. For calculating row 1, there is a formula. Formula is old value minus corresponding key row element into corresponding key column element upon key element. So see this is the old value. Old value is 3 minus corresponding key row element. This is the key row, and the element is corresponding key row element is 5 into corresponding key column element. Key column element is itself 3 upon key element is 5. So this will be equals to 0, 5, 5, 1, 3 minus 3, 0. So here it is 0. Now for this, old value is 5 minus corresponding key row element is 2 into corresponding key column element is 3 upon key element is 5. So what will be the answer? This is 3 2s are 6, 5, this is 25 minus 6 upon 5, this is equals to 19 upon 5. So here we will put 19 upon 5. Come to this, here old value is 1 minus corresponding key row element is 0, corresponding key column element is 3 upon 5. So as this is multiplying with 0, the whole term will be 0. 1 minus 0 is equals to 1. This is 1. Now 0. Old value is 0 minus corresponding key row element is 1 into corresponding key column element is 3 upon 5. So this is equals to minus 3 upon 5. So here we can put minus 3 upon 5. Now the old value is 15. Here come to the solution. This is 15 minus corresponding key row element is 10. This 10 into key column element is 3 upon 5. So this will be 19. This will be 15 minus 6. 15 minus 6. This is 9. Okay, we can put 9. And this is 10 upon 5. That means 2. This is solution. Now we have to calculate Zj. The same formula, 0 into 0 plus 5 into 1. So this is equals to 5. 0 into 19 by 5 plus 5 into 2 by 5. This will be 0 into 19 by 5 plus 5 into 2 upon 5. This is equals to 0 plus 2. So this is 2. 0 into 1 plus 5 into 0. 0 into 1, 0. 5 into 0, 0. That means total value 0. 0 into minus 3 by 5. 0 into minus 3 by 5 plus 5 into 1 upon 5. This is equals to 1. So this is the Zj. Now we have to calculate Zj minus Cj. Zj minus Cj. This is Zj and this is Cj. So 5 minus 5 is equals to 0. 2 minus 3 minus 1. 0 minus 0, 1. 1 minus 0, 1. Again there is one negative value exists, and for optimum solution all the values of Zj minus Cj must be greater than equals to 0. So this is not the optimum solution. So for getting optimum solution we have to construct iteration 3, or we have to construct third simplex table. So now for constructing simplex table we have to find out the key row, key element and key column. For finding key column we will inspect this Zj minus Cj. The minimum value of Zj minus Cj, this minus 1 will be the, this will be the key column, as this is the minimum value. Now we have to find the key row. For finding the key row we will calculate ratio. This is ratio 19 upon 5 into 9. So this will be, ratio will be, this is 45 upon 19. How I calculated this? Ratio 9 upon 19 upon 5. So this will be 9 into 5 upon 19. This is equals to 45 upon 19. Now this will be 5. 2 upon 5. That means 2 upon 5. This is equals to 2 into 5 upon 2, and this is equals to 5. So for finding the key row we have to choose the minimum value of ratio, and the minimum value is 45 upon 19. This is the minimum. This is less than 5, so this will be the key row, and this 19 is the key element. Sorry, 19 upon 5 is the key element. And now come to the third iteration. For solving this, for getting the optimum solution, we are coming to the next iteration. Same process. This is Cj. Cj will be the same as it was in iteration second. This is 5, 3, 0, 0. Basic variables, two basic variables, x3, variables x1, x2, x3 and x4. Now as this is the key element, this will be the departing vector. This x3 will be the departing vector and this x2 will be the entering vector. So in place of x3 here we will write the basic variable x2, and the coefficient of x2 is 3. Here x1, the coefficient of x1 is 5. Now we'll calculate the basic matrix. For calculating basic matrix, same method, we will divide all these values of key row by the key element. We will divide all the values of key row by this key element. So 0 upon 19 upon 5 is 0. Again 19 upon 5 upon 19 upon 5, this will be 1. 1, this is 1. 1 upon 19 upon 5. How we can calculate this? 1 upon 19 upon 5, that is 5 upon 19. Minus 3. Minus 3 upon 5 upon 19 upon 5. This is equals to 3 upon 5 minus 5 upon 19. This is equals to minus 3 upon 19. So this is minus 3 upon 19. Here it is 9. So for calculating this, 9 upon 19 upon 5. So this is equals to 9 into 5 upon 19. That means 45 upon 90. Now we'll calculate this second row. Again the same thing. For calculating the values of second row, there is a formula. This old value minus corresponding key row element into corresponding key column element upon key element. So this is the old value 1 minus corresponding key element of key row, corresponding key row element is 0 into corresponding key column element is 2 upon 5 upon, this is key element, 19 upon 5. So this is equals to, this is multiplying by 0, the whole term will be 0, and this is equals to 1. So here we will write 1. Now this old value is 2 upon 5 minus corresponding key row element is 19 upon 5 into corresponding key column element is itself the number 2 upon 5. Key element is 19 upon 5. So the solution will be 2 upon 5 minus, you can cancel this 19 upon 5 and 19 upon 5. So 2 upon 5 minus 2 upon 5. So this will be equals to 0. So here the value is 0. Now for this old value is 0 minus corresponding key row element is 1 into corresponding column will corresponding key row key column element is 2 upon 5 upon 19 upon 5. So the value will be, this is equals to 2 upon 5 into 5 upon 19. So this will be 5 minus, this is equals to minus 2 upon 19. So here we can write 2 upon 19. This is the old value 1 upon 5 minus corresponding key row element is minus 3 upon 5 corresponding key column element is 2 upon 5 upon key element is 19 upon 5. So this is equals to 1 upon 5 minus, this is minus 6 upon 25 upon 19 upon 5. So this will be equals to 1 upon 5. This minus minus will be plus, and this is 6 upon 25 into 5 upon 19. This is 5. So the solution will be, this is 19 upon 5, and this will be equals to 5 upon 19. 95, 19 plus 6, this is 25 upon 95, that is 5 upon 19. So here the value is 5 upon 19. For this, old value is 0. So for calculating this, old value is 2 minus corresponding key row element is 9, corresponding key column element is 2 upon 5, key element is 19 upon 5. So this is equals to 2 minus 9 into 2 upon 5 into 5 upon 19. 2 minus 18 upon 19. So this is equals to 38 minus 18 upon 19, that means 20 upon 19. So here we can write 20 upon 19. Now we will calculate Zj. So the same formula, Zj, 3 into 0 plus 5 into 1. 3 into 0 plus 5 into 1, this is equals to 5. 3 into 0, 0 plus 5, so this is 5. Next 3 into 1 plus 5 into 0. 3 into 1 plus 5 into 0, this is equals to 3. Next is 3 into 5 by 19 plus 5 into minus 2 by 19. This is equals to 15 minus 10 by 19, that is 5 by 19. So here the value is 5 by 19. Last one is 3 into minus 3 by 19 plus 5 into 5 by 19. That means this is equals to minus 9 upon 19 plus 25 upon 19, that is equals to 16 upon 19. So here we will write 16 upon 19. Now the Zj minus Cj. This is Zj and this is Cj. So 5 minus 5 is 0. 3 minus 3 is 0. 5 by 19 minus 0 is 5 by 19. 16 by 19 minus 0 is 16 by 19. Here we can see that all the values are positive all the values of zj minus cj are positive, all are greater than or equals to 0. That means this is the optimum solution. Optimum solution is here. You can see x1 is equals to, this is x1 and this is equals to 20 upon 19. x2, this is x2, so x2 is equals to 45 upon 19, and the maximizing objective function was, come to the objective function, our objective was to maximize this z, and z is equals to 5x1 plus 3x2. Here 5x1 is equals to 20 upon 19 plus 3x2 is equals to into 45 upon 19. So this will be equals to 5 into 20 is equals to 100 plus 45 into 3 is equals to 135 upon 19. So this is z is equals to 235 upon 19. This is our solution. Constructing next iteration, we have to calculate three things: key column, key row and key elements. So how do we calculate? For calculating key column, we will find out the minimum value of zj and zj minus cj. Here minimum value of zj minus cj is minus 5. So this column will be the key column. For finding key row, we will find out the ratio. We will find out ratio. How we will find ratio? Ratio is equals to solution upon corresponding element of key column. So here solution is 15 and corresponding coefficient of corresponding value of key column is 3. That means 15 upon 3 is equals to 5. Here solution is 10, corresponding value of key column is 5. So this is equals to 2. Here again we will find out the minimum. Here the minimum is 2. So the minimum ratio, the row of minimum ratio will be the key row. So this is the key column, this is key row, and this is this 5. Intersection of key column and key row will be the key element. With the help of this, we will construct our next simplex table.